Hello friends, let's start today's video with a couple of questions. What's the capital of India? Or if I ask, which city is the capital of India? Are these questions different? Well, these two questions are syntactically they are different, but semantically they are similar. Now what do I mean by the word semantically similar? It means you're using different words but the meaning is same. So when I ask the question, what's the capital of India, or which city is the capital of India, the word are different but the semantic meaning remains the same. Why am I talking about all these things? Well, imagine you go to a website where from you purchase a product or you are planning to purchase a product. You will find a chatbot over there to whom you put forward certain questions. The bot gives the answer. So your framing of question will vary from individual to individual. The way you frame, the way you syntax the statement will vary from individual. But the bot is so smart that it can understand the semantic differences of these questions and will come up with the right answer. I believe you can figure out I'm talking about information retrieval technique that is making use of NLP, natural language processing. So what actually happens in this case? Well, the bot has got predefined knowledge, and this knowledge can be in the form of a database or like what you can see right now in front of your screen, a JSON file. Here I have framed different objects which has got a question with a relevant answer. So imagine your client is selling some product and the client has jotted down the most frequently asked question and has given it to you in this file format. The client now wants that you prepare a chatbot where the end user, the general subscriber, can come across and write different question. So syntactically the questions of the users will vary, but semantically they will be similar. And the bot should use some mechanism to figure out the syntactical differences and can closely match the semantical similarity and then provide the right answer. So in order to do this, what do you need? Well, you need something called term frequency and inverse document frequency, that is called TF-IDF, and you also need something called cosine similarity. All these things you need that will come across machine learning or NLP. So let me first run the application and then I will come to my tech stack. So I have a file called index.py which hold a bit of code that will do a small magic. So let me open the file, and unfortunately I cannot expand all the code. As you can see over here, I'm giving a call to an API. Well, I did not make use of Django, rather it is based on FastAPI. So let me open my Postman. My application is running very smartly. It's right over here. It's running over here. Don't worry about these numbers because okay, let me tell you about the relevance of these numbers. Because you have to convert your text into vectors, and that's the reason why TF-IDF and cosine similarity will be useful. Okay, nonetheless, my application is running, and let me come back to my Postman. And I'm supposed to ask a question. So I have a FAQ file over here, and again I said the end user can come across any form of questions. So syntactically the sentences will be different, but semantically the statement will be matching. So you choose any question. Over here 10 questions are there. So let me ask a question like over here, what is tokenization and how to tokenize text? So let me frame the question in this way now. I'm passing a JSON, so I'm saying that would you please let me know about tokenization? How about this? Tokenization. So that's my question. So would you please let me know about tokenization? So let me send the answer, and here the answer comes. Tokenization split text into word, sentences, or subword. And please go and check that exactly that's the answer for the following question. But did the question match with the question that is there in my JSON file? This is what called syntactically the question is different, because I have got different words, but semantically this meaning is same. And that is what this retrieval based chatbot is supposed to do. And that's the power of NLP. Well, let's reframe this question again. Okay, I would love to know about tokenization. Let me clear the response and let me pass it again. Click the send button, and again the same answer comes. But again you see both the statements were syntactically different, but the semantic meaning of the statement were very similar, isn't it? Okay, great. So now let's try to come across one more question that is called cosine similarity. This is really very important in order to do this kind of problem solving. Okay, so let me put the question in this way now as I would keen to know about cosine similarity. But look over here, the sentence is totally different. How do you calculate cosine similarity between two texts? So let me now see what answer do I get. You use Scikit-learn. Exactly, Scikit-learn is under the machine learning, and you would find the cosine similarity, find the similarity between two vectors. Exactly. So you can figure out the question which I passed and the question that was there in my question set, they are not similar, but it smartly gives the answer. So to do the cosine similarity, we have to make use of TF-IDF, and that's what this program is all about. So before we bind up, let me ask one last question. Okay, do cosine similarity has got anything to do with TF-IDF? Let me put it this way. This is a very complex question. Do cosine similarity has got anything to do with TF, that is term frequency, and inverse document frequency? Well, this is a very complex question. I don't know whether it can give the answer to this question or not, and it does give the same response. Let me clear the screen. Let's put the question again, and it does give you a response. You can use the same response is coming. The smart thing is that it is able to handle the question that you have given. It did come across answer, right? Maybe the answer is related with this point, that's not with this one, but still it could make out the answer, and that's the good part. So if you pass a question now in this way, would you let me know about TF-IDF? Okay, great. And let's come up. You can use NLTK stop word to filter out the common word from your text. So it came up with this answer. Okay, so it is using this one. You can use NLTK stop word, so it is using this particular answer. Nonetheless, it got some answer to the question. So even if your sentence is varying, but the beauty is that it is able to figure out the semantic meaning of the statement and is able to produce output. Okay, so in order to achieve this, what tech stack did I use? As you can see, I'm using FastAPI to create the RESTful API. Of course, East or West, Python is the best. I'm using data handling because I'm reading the data from my FAQ, which is in the form of a JSON file. I'm using machine learning for performing TF-IDF that converts your text into numerical vectors, and I'm using cosine similarity to find out the similarity. That means semantic similarity between the statement that is given by the user in comparison with the answer that is stored inside the FAQ. And if you have to achieve this, you have to go for a pipelining. And what pipelining do I need? I have to go for NLP pipelining in the form of sentence tokenization, words tokenization. So these are called text tokenization. Then I have to use something called stop word for removing the word which are not that going to affect a lot in the similarity meaning. And then I have to use word-net lemmatizer. So lemmatization is a process of reducing the word into the compact meaning. Okay, and I have got a file. That means I can store the file, the questions in the file, or I can make use of database. But right now I'm using the file-based dataset. And lastly, I'm using asynchronous gateway interface in the form of evcon. Okay, and that's the way I'm running this particular file. So these are my tech stack in order to achieve what? In order to achieve a retrieval-based chatbot. And it is very important these days because every client would love to have a chatbot so that the end user, whatever question they put forward, the chatbot can understand. And for that reason, you have to go through the following NLP pipelining. So these are the stages that my program has gone through in order to achieve the following output, which you can see right over here. Okay, so this was the first video in context to the retrieval-based chatbot, and I'm sure in my coming days I will come across more such video. Until then, have a nice time. Bye bye.